Hello everyone, guys. My name is Amit Kumar Singh and I'm your master teacher with Dantu. And guys, here we're going to have the discussion of the KVPY 2018 SX Part 1 Mathematics. So guys, I'm just going to pick one of the very wonderful question and explain the solution. Okay, so now let's just quickly look at that application. But as you can see on the screen, the question says, suppose A is a 3 cross 3 matrix consisting of the integer entries that are chosen at random from the set. The elements are minus 1000, minus 99 and so on up till 999 up till 1000. Let P be the probability that either A square is equal to minus I or A is a diagonal matrix where I is the 3 cross 3 identity matrix. Then the options are probability P is less than 1 upon 10 to the power 18 equal to 1 to the power 18, that is option B, and option C is like P lies between 5 square upon 10 to the power 18 to 5 cube upon 10 to the power 18, or P is greater than equal to 5 to the power 4 upon 10 to the power 18. So bacho, for this particular application, if you'll ask me now, this question is not that difficult. Okay, I hope you must have done some PNC applications in matrices, right? So this is just one such classy application of that question, right? So I'll just explain the logic of attempting this question. So now bacho, let's just try to see how are we going to attempt this one. So if you just look at the question now, it is saying a matrix is 3 cross 3, right? They're telling me that can you let P be the probability that either A square is equal to I or A is a diagonal matrix. The very first thing I'm just going to do, since I want to know the probability, so first of all guys, let me just try to find out the total number of cases. Okay, total number of matrices that I can have. Okay, if I am having a 3 cross 3 matrix, that means I'll have to fill up the 9 places, right? So total number of cases will be what, guys? For each place, if you try to fill up each place in a 3 cross 3 matrix, every place, for every place you'll be having an option of 2001 options, right? That is, the digits that we are using now are from minus 1000 to 1000. So for each place we'll have 2001 options. So for 9 such places I'll be having 2001 to the power 9. This is the total number of cases. Now question says, tell me the probability says that this matrix A is such that either A square is equal to minus I or A is a diagonal matrix. So now if I want to find out probability of that event, guys, now I'll try to find out the number of favorable cases. Okay, so now I'm just trying to find out the favorable cases. So how am I going to do that? For that, guys, I can see I have question says that two conditions are favorable to me. Either A square is equal to minus I, that is one such possibility, and I hope the moment I'll see this application now, A square is equal to minus I, okay, this is something which is not possible, okay. Reason is that if I try to take the determinant value on both the sides, you can easily see determinant of A square is coming out to be like minus 1, which is something which is never possible. Okay, so if it is not possible, so guys, from this case I cannot have any favorable cases. Okay, so how about the other case? Other case is that, guys, if you try to look at the question, in the other case they are telling me that matrix A is a diagonal matrix. So if a matrix is a diagonal matrix, guys, again this is one such very beautiful condition. Okay, so if I want to know how many such matrices I can have, so guys, I can comfortably say, corresponding to this case, if I want to find out the favorable number of cases, guys, it's going to be like, if the total number of cases is going to be like what, 2001 to the power 3, cause in diagonal matrix you leave the leading diagonal, all such entries has to be 0. All the entries other than the leading diagonal now, all of them will have to be 0. That means that for each leading diagonal entries, that is just for the 3 positions, for each position you will have 2001 options. That means 2001 to the power 3. So if you know the total number of favorable cases, if you know the total number of cases, so how about we write down the probability? Probability will be favorable cases upon total number of cases. If you try to simplify it, it becomes 1 upon 2001 to the power 6. I hope no one of you will have any problem if I replace 2001 by 1000. Okay, the moment I will replace 2001 with 1000, guys, inequality is going to be, now this will lead to less than 1 upon 1000 to the power 6. I hope no one will of you have any problem that, if I try to replace 1000 by 10 cube, which is like 10 to the power 18. I'm sure all of you can understand this point. The moment I'll get this expression, guys, I'll say my probability value will always be less than 1 upon 10 to the power 18. So as per me, guys, this is going to be this answer for this application, right? So if you try to understand that, if you want to confirm that which of the option is the correct one, so guys, as you can see in the screen, my probability value is obviously going to be less than 1 upon 10 to the power 18. So this is what we have got corresponding to this application. I'm sure bacho, all of you would have understood the solution and would have appreciated it. Okay, so just stay tuned for the next one, because we'll be seeing you again with one more beautiful application. So see you all. Thank you.